we are going to be doing question 4 in the workbook. So the question asks on page 18. Yes, I should write that. So the question asks, what is the gravitational field strength on the surface of Mars is 3.7 newtons per kilogram. So let's make a list of givens. So our gravitational field strength, so our acceleration on Mars is equal to 3.7 newtons per kilogram. Okay. Our next thing says, what does a person weigh on Mars if she weighs 634 newtons on Earth? So that means our force of gravity on Earth is equal to 634 newtons. And we're trying to solve for the force on Mars. Another given we know the acceleration of gravity on Earth is equal to 9.81 newtons per kilogram. Okay, with this given information, we can now try and solve for our mass on Earth. So we know that our force is equal to mass times acceleration. So our force on Earth is equal to our mass times our acceleration on Earth. If we're trying to solve for mass, or unknown, because our mass always stays constant, we can isolate our mass. So mass is equal to our force on Earth divided by acceleration on Earth. Now that we have our formula decided, we're going to sub in our values. So our mass is equal to our 634 newtons divided by 9.81 newtons per kilogram. So our mass comes out to be, when we put into our calculator, 64.6279 kilograms. Okay, we now have our mass. So we're now going to repeat this same equation, but this time solve for the force on Mars, so her weight on Mars. So our force on Mars is equal to our mass times our acceleration on Mars. So doing the same thing, our force on Mars is equal to, we're going to use this value here, 64.6279 kilograms times our acceleration on Mars up here of 3.7 newtons per kilogram. When we solve for our force on Mars, we're going to get the value of 239.094 newtons. When we look at our original givens, we can see that we have 2 sig figs. So we're going to round this off to 2 sig figs. So our force on Mars is equal to approximately 240 newtons, which we can also write as 2.4 times 10 to the 2 newtons. Perfect. We're now going to give ourselves a therefore statement. Therefore, she weighs 2.4 approximately 2.4 times 10 to the 2 newtons. So this is our part A. Okay, now going on to part B. Let's see what part B is asking for. So what is her mass? What is the mass of Mars? So we now want to find the mass of Mars itself. If the radius of Mars, so our radius of Mars is equal to 33.4 times 10 to the 6 meters. Let's go look back and see what other givens we already have. We already know we've solved for the mass of this person on Mars. We can also use this mass. So this mass is equal to 64.6279 kilograms. Additionally, we know our gravitational constant is equal to 6.67 times 10 to the negative 11 newtons per meter squared divided by kilograms squared. Okay. And our last value that we know is we know our force on Mars. So our force on Mars is equal to 239.094 newtons. Perfect. We're now going to sub in these. We're now going to figure out what equation we can use to solve for our mass. So to solve for our mass, we have the equation of force of Mars is equal to your gravitational force times mass 1 times mass 2 divided by your radius squared. Perfect. Right now we have mass 1, and we're trying to solve for our mass of Mars, which we can also say is our mass 2. So we're going to solve for that. So the first thing we're going to do is we're going to isolate that variable. So our second mass is equal to our force on Mars times the radius squared divided by your gravitational constant times mass 1. Now that we have our equation, we're going to sub in our values. Let's maybe give us a separation here. Okay, so our mass 2 is equal to 239.04 newtons times our radius squared, which is 3.4 times 10 to the 6 meters squared, divided by our gravitational constant, 6.67 times 10 to the negative 11 newtons per meter squared, divided by kilograms squared. And finally, we're going to multiply this by our mass that we solved for over here, which is our 64.6279 kilograms. Let's extend this over. Okay, when we plug this into our calculator, we're going to come out with an answer of 6.472 kilograms. Okay, now given this radius, we can see this radius has 2 sig figs. So we're now going to round our mass off to 2 sig figs. Which is so mass 2 is equal to 6.4 kilograms.